chat box, right? So, okay, so you were saying, Asha, that you have a problem in work done in variable electric field, right? Variable force.
Yes,
So,
sir.
what do we know? That yeah, let's say that for a fixed or a uniform electric field, right? Let's say this is uniform electric field, and this is some charge put in here, right? So we know that F is QE in this uniform electric field. And we are taking this charge from, let's say, point A to point, or let's say initial point to final point. So we have understood that the work done would be work done in bringing a charge from initial point to final point in the presence of this external electric field. This would be simply Q E dot R final minus R initial. This we know, right, Aisha?
Yes, sir.
So if this field is not uniform, right? So if this field is not uniform, so this would be simply, this is for the uniform field, and let's say that this is minus F external, not minus. But this work is done by this external electric field. We have to apply external force, right, on this charge to do some work, right, Aisha? So work done would be F external dot dr, simply, right? And
Yes.
yeah, so you see that this is the case for the non-uniform electric field, because we have an integral. If this would have been a uniform field, so that would have been simply what? That would have been simply F external dot S, right? Which gives us this, right, Aisha?
Yes.
Yeah. So you know that what is F external? F external is simply minus of F, right? And F we know. So we can replace the F external value, and this would be simply, let's say, initial, final, and this is minus QE dot dr. So in these type of question, you will be given some form of electric field. Let's say that E is 3x plus 2y I hat plus 3 y square j hat. So what kind of electric field is this? Mariam and Aisha. Yes, Aisha, what kind of electric field is this?
Uniform.
Yeah, variable or uniform? Yes. Your your mic is also not working. So maybe you have some internet issues, Aisha. So Mariam has mic issues. You have internet issues. No, 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 Aisha. You see that these are x and y variable. E is not something like 3i plus 4j. So E, if this represents that it is not this is not dependent upon some variable, right? It is uniform. But for this case, you see that E is dependent upon x and y, right? So which means that if I increase x or y, or if I decrease, or if I change x or y, so electric field will change, right? If I change x, y, electric field will change. And in this case, if I change x, if I change y, if I change z, if I change any of the variable, so this electric field will not change, right? It will not change in the x direction, it will not change in the y direction, it will not change in the z direction. But for this case, if you move, if you are here at x equals to 1, so this would be 3 into 1. If you move into f x equals to 2, so it will change to x equals to 2, right? So this is a variable. variable electric field. Is that clear?
Yes, sir.
Yeah. So for variable electric field, this would be the work. So work done, let me write it as 1, 2, would be 1 to Q E dot dr. This is the work done. And we also know that what is work done in with respect to the potential. What is work done? This is simply Q V final minus V initial. Right? We know this, right?
Now, could you repeat?
Yeah. So we know that work done with respect to potential, right? This is simply Q VB minus VA. V
Yes,
of,
sir.
right? This we know. So that is what I have written here. In place of AB, I have written initial final. In this way, we can understand it more properly, right? So if we are bringing some charge from, let's say, this A point to B point, right? So work done would be simply Q of whatever potential is at this point, VB minus VA. This we learned in the first part, right? So in
Yes,
here,
sir.
yeah. So when we were doing this question, so in the homework, you have sent me your homework, Aisha, right? But I had also asked about the work done in bringing the charge from O to E. This was also the question, right? Yeah. So yeah, this was the question, from work done from O to E. So this you guys didn't try. And Mariam, you didn't send me your homework. Yes, Mariam, what about the homeworks? Yeah, you didn't send me your homework. So if you don't practice, then you will forget, right? I also sometimes forget. So yeah, this is human nature. So if we don't practice, then we will forget everything. So that is why I keep repeating these things, and yeah, you guys have to practice on your own. Okay. Yeah. So is that clear, Mariam and Aisha? Work done in the presence of electric field.
Yes, sir.
Yeah, and you can have two kinds of electric field: variable one, and uniform one. So this represents variable one. This represents uniform, right? Okay. So we were doing what? Yeah. In the previous class, we found out the relation between electric potential and electric field. But before we do that, let me simply just quickly revise whatever we have. So we will come to this point later. And where are these guys? Where is Saad? Where is Hasib? Okay. Yeah. Okay. So what we have learned so far, that work done is potential is what? Potential is work done in bringing a charge from infinity to a fixed point, uh, right? Unit positive charge. So this is the electric potential, right? We have source charge, right? And this charge is placed at infinity, and we are bringing this charge to this point, let's say P, right? So from here to here. So electric potential is work done in bringing the charge from infinity to point P. So we can write W as QV, right? So, but whenever we have potential difference, so whenever we have potential difference to potential, so this would be simply work done would be QVB minus VA. This we will come at later. But whenever we have single potential, not a potential difference, right? So then this work done is simply Q into V, right? Then what did we learn? We calculated the electric potential of a point charge. At that came out to be KQ by R, right? KQ by R. So this was the source charge, not this charge, right? And then we understood about the electric potential of multiple charges. So let's say this is the test charge and this is Q1, this is Q2, this is Q3. So electric potential was simply algebraic sum, right? And this came out to be KQ1 by R1 plus KQ2 by R2 plus KQ3 by R3. This we learned, and we also learned that what is the potential, electric potential of dipole. So that came out to be Kp cos theta by R square. So we saw that potential varies as 1 over R square for the dipole, but electric field varies as what? Aisha and Mariam. Electric field varies as for the case of dipole.
1 by R square.
Yeah, R for the case of dipole, for the case of dipole.
R square.
You guys. So 2 Kp by R cube. And this is the axial minus Kp by R cube, equatorial. So R cube, right? Okay. And then we learned about the work done. Yeah, R2. No, R cube, R cube. Okay, then we learned about the work done in external electric field. So this is simply minus Q E dot R final minus R initial, right? So work done in bringing a charge from initial point to final point. And in the presence of non-uniform electric field, this was simply minus Q and initial final E dot dr. This we learned. And then we also learned that work done in bringing a charge from A to B is simply what? Q VB minus VB, right? So if we are bringing some charge from infinity to point P, right? So that would be infinity to point P. So that is called what? So that is called electric potential, right, guys?
Yes, sir.
Yeah, and if we are bringing the charge from A to B, right? From A to B, then this will be called QVB minus VA is equals to W. So this is what? This is the potential difference. right? This is the potential difference and this is the potential. So if we are bringing a charge from infinity to point P, then it is called potential. But if we are bringing a charge from A to B, so this will be called potential difference. Right, guys?
Yes, sir.
Yeah, this is the difference between electric potential and potential difference. Okay. And then what did we learn? Then we learned that if we are bringing a charge from A to B, right? So this is, or let me write it as, so Q, or let me write it as this. So in the presence of uniform electric field, W is what? Initial to final. This is minus QE dot RF minus RI, right? And this is related with potential. So this is Q VF minus VI equals to minus QE dot RF minus RI, right? This we know, Q VB minus VA. So Q cancel and we can relate V final minus V initial, and this is QE dot R final minus R initial, right? So this is the relation between electric or potential difference and electric field. So we can write this as dV equals to minus integral of, if I write, so this is E dot dr, right? And if I integrate on both the sides, so, oh, who left? Mayam got disconnected. Okay, so if I integrate it, so this would be integral of, so if I integrate it, this would be V2 minus V1, right? Minus E dot dr. And this is 1, 2. So this is the relation between potential and electric field. We can write this as simply V equals to E dot dr minus. Okay. And if we change this integral, if we take this integral in the left hand side, so this will become E, and this would be equal to minus of dV by dr. So this we learned in the previous class, right? So is that clear, Aisha? This we did in the previous class.
Yes, sir.
So any doubt up to this point?
No, sir.
Okay. Okay, so now let us do some questions based on this, and then let's wait for Mariam. She got disconnected. Let's wait for Mariam. And so you have already done the differentiation and integration, right, in the 11th portion.
Yes, sir.
Yeah, so okay, so you guys in the previous class said that you don't want to repeat that. So yeah, we will directly do some questions. Okay. Okay, so let's wait for Mariam, and yeah, let's wait for Mariam, right? Yes, hello, Mariam.
Yes, sir.
Yeah, you got disconnected. So up to this point, we did in the previous class, right?
Yes, sir.
Yeah, so this is how we call that electric field is the gradient. Gradient meaning that we are taking the differentiation with respect to r. So d by dr is called the gradient. Okay. So that is what our topic is. Electric field, electric field as gradient of potential. So yes, so d by dr, whenever we take the differentiation with respect to position, so that is called gradient. And this minus sign represents that the direction of electric field would be from high potential to low potential. What do I mean by that? So let's say I have 2 points, right? Let's say this is point A, this is point B. Here the potential is, let's say 15 volt, right? And here potential is 25 volt. So what would be the direction of the electric field? Right to left or left to right? Yes, guys, right to left or left to right? Did I say same thing again?
Left to right.
Yeah, left to right, left to right, left to right, or right to left. Which is the B to A? Yeah, B to A. Why? Because this is the higher potential, right? And this is the lower potential. So this minus signifies that we always take the direction of electric field with from high potential to the low potential. Okay, so this is what is meant by these this negative sign and these gradient. Okay, so now let us do some question and so that we can understand. Uh, so this we have already done, right? So no need to note it down again. And this part, you guys. So did you guys note down this part in the previous class? Yes.
No, sir.
Yeah. Did you guys note it down in the previous class?
No, sir.
Hmm. Yeah, I guess you guys are saying because yeah, you Mariam, your voice is so low. So okay, I guess that you guys have noted it down. So let's do some questions. What kind of question can be asked from this formula, right? From this concept. So let's say that you would be always given some function of potential, right? So let's say V is 3x squared. Okay, potential is given as the function of x. So you see that potential is a scalar quantity or vector quantity.
Scalar.
Yeah, scalar quantity. And electric field is what kind of quantity? Yes. Electric field is what kind of quantity? Scalar or vector?
Vector.
Vector, right? Absolutely right. So this is a vector quantity. But you see that where is the direction? So this is only telling us about the magnitude part, right? So if we want to calculate the electric field in vector form, so this would be how much? This would be EXI plus EYJ and EZK, right? So this would be the electric field. And we can write Ex as minus of dV by dx. and we can write Ey as minus of dv by dy, and Ez as minus of dv by dz. Okay, guys, then we can plug in the values. So we are given v equals to 3x square. So Ex would be how much? Ex would be simply minus dv by dx, which means that minus of d 3x square by dx, which is how much? So this is minus 3 into 2 and x, right? So minus 6x. This is Ex. And Ey would be how much? Ey would be minus dv by dy, which is minus 3x square by dy, which is 0. So Ey is 0. Similarly, your Ez is also 0 because in this function you don't have a z part. So the electric field would be simply how much? This would be simply E is xi plus Ey j and EZK. So this is simply how much? Minus 6xi hat plus 0 plus 0. So only this one. Is that clear, guys?
Yes, sir.
Yeah, you guys please note it down, and then we will complicate the questions more. Yeah, whenever you guys have finished noting, please tell. Finished. Aisha, finished. How did we get 2x? Oh, so uh, differentiation of x square, right? So what is the differentiation of xn? This is n x n minus 1, right? You guys say that you already know differentiation. So this would be what? 2x 2 minus 1. So 2x, right? This 3 is taken outside. Yeah, should I talk about differentiation more, Aisha? If you want to, then I will talk about differentiation first. Yes, Aisha.
Then I remember a bit of it.
Oh, okay. Okay, then it's fine. Yeah, Mayam is saying that I should talk about differentiation. Okay. So yeah, so let me just quickly revise the differentiation part. Okay. So we have 4 special functions. first is the algebraic or the polynomial function. Okay. So for algebraic function, this is a differentiation of, as I talked about before, this would be simply n x n minus 1. So let's say I want to calculate the differentiation of x to the power 6, right? So d by dx of x would be how much? This is the power. So 6 comes in here, and then in the power 1 is minus. So 6 minus 1. So 665. Right. So this is the differentiation for a polynomial function. Okay. And what about this kind of, so let's say that my y is root x. Okay. So what is the power of x in here? Yes. What is the power of x? Yes, guys. What is the power of x? Root, square root. So if I change it to the power, this is half, right? Then what would be the differentiation of this? So d by dx of x to the power half, right? This would be half is power, so half is taken beside here, right? And x half minus 1. So this is half x and half minus 1. So this is minus half. So this goes in the denominator and this will become x to the power half. So 1 by 2 root x. So this is the differentiation of x to the power half. So this is the algebraic function differentiation. Okay, guys. Yeah. And if I want to calculate the differentiation of trigonometric function. So trigonometric functions are what? So just two function we should remember, sin x and cos x. So differentiation of sin x is cos x, and differentiation of cos x is what? Do you guys remember? Yes, Aisha and Maria, you guys remember or not? Yeah, minus of sin x, right? So this is the differentiation of trigonometric function. And then you have logarithm or exponential function. So exponential function is ex, and differentiation of ex is also ex. Right. So this is the differentiation of exponential function, and then you have logarithmic function. So which is what? Log x. So differentiation of log x is what? This is simply 1 over x. Okay, so these are the special differentiation of special functions. And then what are the rules of differentiation? Okay, so first is that, yeah, so this you guys, I think, okay, so rules of differentiation. First is that whenever you multiply with, so y is k of fx, some constant is multiplied, right? And then you want to take the differentiation. So this would be simply constant would be taken outside. And then you take the differentiation of the function. So let's say that I am in the previous case, I was calculating the differentiation of 3x squared. So function is x squared, right? And 3 is the constant term. So 3 is taken out. If I am calculating dy by dx, so 3 is constant, 3 is taken outside, and this would be dx squared by dx. Right, and the differentiation of x squared will be how much? So 3, 2, and x2 minus 1. So 3 into 2x, which is 6x. So this is the first rule. Right, guys? And the second rule is that the differentiation of a constant term. So y is some constant term, right? Let's say y is 5 or y is 3 or y is 2. So these kind of terms. So for these cases, the differentiation would be simply 0. Differentiation of a constant term is 0, right? And let's say that y is 5. So differentiation of 5 would be 0. Okay. And the third property or third rule is that the differentiation of two functions which are sum. So y is u plus v, right? So for u plus v, dy by dx would be simply du by dx plus dv by dx. Okay. So let's say that I have a y which is x5 plus sine x. Right, so I have one function and I have the other function. And let's say I have one more function, which is, let's say, x cube. So dy by dx of whole would be d by dx of x5 plus sine x plus x cube. Right, so this would be d by dx of x5 plus d by dx of sine x plus d by dx of x cube. So this would be simply, this is 5, so 5x4, this is cos x, and this is 3x squared. So this would be dy by dx. Whenever we have sum of different functions, right? And then we have this multiplication rule. So y is multiplication of two functions. In this case, what we do is that we take one outside and we take the differentiation of the other one. And in the second case, we take the other one outside and we take the differentiation of first one. So let's say that I want to calculate the differentiation of x squared into sine x or x squared into log x. Okay, so this would be what? Dy by dx of this would be d by dx of x squared into log x. So u is how much? U is x squared, v is log x. So u dash, which means that u du by dx, right? Or let me write it as du by dx. This would be how much? 2x. And then dv by dx. So this would be 1 by x, right? Now we can plug in the values. So this would be First is outside, so x square is outside. Differentiation of dv by dx, which is 1 by x, plus v is outside, and the differentiation of x square, which is 2x. So this would be how much? X cancel, and we have x plus 2x log x. So this is the differentiation of multiplication. Any doubt, guys? Any doubt? Yes.
No, sir.
Okay. And then you have this. Then you have this division rule, right? U by V. So for the case of U by V, this is simply U dash V minus U V dash divided by V square. So this is, and U dash is du by dx, and V dash is dv by dx. So these are the 5 set of rules, and those are the special functions: trigonometric, logarithmic, exponential, and algebraic. So this much we need to know in the for the case of physics part. But if you have mathematics, then they are more complicated things, right? And you also know that the reciprocal or the inverse of differentiation is what? This is integration, right? So integration of y dx. And we know that integration of x n dx is how much? This is xn plus 1 and n plus 1 plus c. So yeah, these are the uh, things, the basic concepts that we need to know beforehand. Okay. Yeah, so this differentiation part is clear to you guys? Or do you guys want to note it down? But this is not that important. Yes. Yeah, what are you saying, Maria? Mm, can you hear Aisha what Mariam is saying?
No, sir.
Yeah. Okay, so you write it in the chat box, Mariam. Sorry about that. Please fix your microphone in the next time. Yeah. Okay, so I should go ahead because I wanted to do potential energy. Yeah. Okay. Okay, so we were doing the what electric field as the gradient of potential, right? So one case we did, which was V was let's say 3x square. Now let's say that V is so this is function of x only. Let's say I have V, which is 3x square y, right? So electric field have 3 components. One would be Ex, which is, you guys calculate me and tell me what is the answer. Quickly calculate and tell me what is Ex, Ey, and Ez. And write it in the chat box, guys. Yeah, write it in the chat box. Yes, guys, what did you get? What is Ex? Yes, guys, what is Ex? Please tell me the answer, guys. You guys calculate, work on your own, and tell me the answer. Yeah, are you guys solving? Okay, let me help you guys. So Ex would be what? Simply, this would be minus of dv by dx, right? And remember, this is the partial differentiation. So in partial differentiation, what we do is that we only take x as variable. All the rest are constants. So 3y is constant, right? Minus d by dx of 3x square y. So 3y is taken outside. Minus 3y is outside, d by dx of x square. So again, x square is what? 2x. So 3y into 2x, which means minus 6xy. Okay, and then this is the Ex. So did you get this one, guys? And what about Ey? So Ey would be minus of dv by dy, which is minus d by dy of 3x square y. So the function or the variable is y. So only y remains and all the rest ones taken outside. So minus 3x square y dy by dy. So this is y. So this would be minus 3x square simply. And Ez would be 0 because we don't have any function of z. So the electric field Ex is how much? Ex is minus 6xy, Ey is minus 3x square, and Ez is 0. So your electric field would be how much? This would be minus 6xy I hat minus 3x square j hat plus 0. So this is your electric field. Is that clear, guys? Yes. Please quickly note it down. Yeah, please quickly note it down, and then we will do one more question, and then we will learn about potential energy. Yeah, whenever you guys have finished noting, please tell me. So tomorrow there would be a fortnightly test, right? And the exam would be on work done and potential. So up to that point only. Up to this point, yeah. So in the previous exam, only Aisha was there. Mariam, please be there for that exam.
Done, sir.
Done. Okay. So, Mariam, done. Okay. So the next question is that the potential is given by V is equals to 6xy plus 2xz square, right? And we need to calculate electric field at point what let's say 1, 2, 3. So this is the proper complete question. Okay, so first potential is given and we need to find out what is electric field first, right? So V is given, which is 6xy plus 2xz square. So you guys can see that this is function of x, y, z. All the three are variables. So all the three components would be there. Oh, who left? Yeah, Mariam got disconnected. So first, let us calculate what is the x component. Minus dv by dx. So minus of 6xy plus 2xz square. So again, sum of two functions. So this would be minus d by dx of 6xy and minus d by dx of 2xz square. So we are calculating the differentiation with respect to x. So y and 6 is taken outside. So 6y and x cancel out, dx by dx is 1, so only 6y. Oh, let me write it as. And then I have z square again. 2z square is taken outside. So 2z square dx by dx. So this is 1, this is 1. So I have minus 6y minus 2z square. This is my Ex. Right, Aisha?
Yes.
And what would be Ey? So Ey would be simply minus d by dy of v, which is, so this is d by dy of 6xy minus d by dy of 2xz square. This is not a function of y, so this is 0. And this is how much? So minus 6x is taken outside, dy by dy, which is minus 6x. So this is my Ey, right?
Yes.
And then Ez is how much? So Ez is minus dv by dz. Yeah, so your internet is not working properly, Mariam, right? Okay, so we are just calculating the electric field due to this potential. So what would be that? Let me directly write the answer, and you guys check that. Okay, so 6xy doesn't contain z function, so that is 0. Only minus 2xz square by dz. So 2x is taken outside, and d by dz of z square, which is 2z. So minus 4xz. This is Ez. So our electric field would be how much? E would be EXI plus EYJ plus EZK. And this is the function of x, y, z, right? So Ex is how much? Minus 6y minus 2z square I hat and minus 6xj hat and what? Minus 4xz and k hat. Okay, so this is the electric field. But they want us to calculate the electric field at which point? This point. So this is x, this is y, this is z, right, guys? So value of x, y, z is given. So we can put the values in here, and we will get what? So y is 2. So minus 12 and minus 2 into 3 square. So 3 square is 9 to 18. So 18. This is I hat minus 6 into 1 j hat and 1 into 3. So 12k hat. So this would be minus 30i minus 6j minus 12k. This is my electric field at 1, 2, 3 point. Any doubt in this question, guys? Yes.
No.
Yeah, so you guys please quickly note it down, and then we'll start the potential energy. Yeah, should I scroll down the screen, guys?
Yes.
So whenever you guys have finished, please tell me. Done. Aisha, done.
Yes, sir. Done.
Yes, yes, Mariam. Yeah, what are you saying? You have a doubt? Ah, done. Okay. Aisha, what about you? Done. Yeah, Aisha. Are you there, Aisha?
Yes, sir.
Ah, okay. So now the next topic is electric potential energy. Okay. So electric potential energy. Okay, so what is that? We learned about electric potential. We learned about work done, right? So in the 11th class, we have learned about the work energy theorem, right? So change in kinetic energy or change in potential energy gives you uh, the work done, right? So what is the electric potential energy? So it arises due to the conservative interaction of charge in electric field, right? So what do I mean by conservative? So when the forces that are involved are conservative, which means that work doesn't depend upon the path, right? So then that force is called conservative, and those conservative interaction creates this potential energy. Okay, so who got disconnected? Host got disconnected. So this is potential energy. But what is the definition of this potential energy? So let's say that you have two charges, right? Let's say you have this Q1, Q2 charges, right? These are at infinity. And you have two fixed points. So let's say you have A and you have, let's say, B, right? So first what you do is that you take Q1 to A, right? So, and then after that, you take Q2 to B. So total work done in bringing both charges to a fixed point is called the potential energy. Okay, or we can also say that we have taken this Q1 charge and Q2 charge from infinity and we have brought them here. So this is making a system, right? So we can also say that total work done to make a system is called potential energy. Right. So any of these two definition you can choose. One is that you take Q1 charge from infinity to A, so there will be some work done, right? And then after that, after you have taken Q1 to A point, and then what you do is that you take Q2 point from infinity and you bring them in here, bring that in here at B point. So that is called, and there is some total work done. So that total work done is called the potential energy. Is that clear, guys?
Yes, sir.
Yeah, please note it down and then we will derive the formula. Please note it down. Yes, whenever you guys have finished noting, please tell me.
Done.
Okay, so now let us derive what is the formula for potential energy. So I had said that first I take this Q1 charge, right, to a fixed point A. So work done would be what? This would be Q1, right? And VB minus VA, not VB, but V infinity, right? And VA. Is that clear? This would be the
Yes,
work done, right? But you see that there are no electric field, right? So if there are no electric field, if there are no other charges, if there are no other charges, so the V infinity and VA would be how much? So we are taking V infinity. Oh, well, let me write this as, so we are bringing this this Q1 charge from infinity to a point. So this would be Q1, and what would be here? This would be V infinity or VA. Yeah, what would be here? VA, right? So this would be VA and V infinity. So VA is 0, V infinity is 0. So this would be 0, right? Is that clear, guys? Okay, so now I have this other charge and I am taking this to this point B. Okay, and the separation is R. So this charge is Q1. So now you guys see that I have some Q1 charge here, right? So I have this Q1 charge. So this will create some potential on B, right? This will create some potential on B. So this was due to Q1. Now let's bring Q2. So bringing Q2 from infinity to B, right? So this would be Q2 and VB minus V infinity. But potential and at infinity is 0, right? Potential at infinity is 0 because potential goes as 1 over R. So at infinity it is 0, right? So this is 0. And Aisha, you tell me that what is VB? VB arises, potential and B arises due to this Q1 charge. So what would be VB? Aisha. K cube, but what is what Q? Q1 or Q2? Yes. Due to this Q1 charge, absolutely right, Asha. That would be KQ, but KQ1. So this VB would be KQ1 by R. Yes. Yes. So now what we will get? We will get KQ1, Q2 by R. So the total work done would be how much? Total work done, which is potential energy. This is V infinity A plus V W infinity B, which is 0 plus K Q1 Q2 by R. So this would be potential energy, which is K Q1 Q2 by R. Okay, so whenever we have two charges, right? Q1, Q2. So the separation is R. So potential energy would be simply K Q1 Q2 by R. Is that clear, guys?
Yes, sir.
Yeah, so please note it down. Note it down from here. So this is for Q1, this is for Q2. Okay, I have, so this is potential energy due to 2-point charge, and let's say I have 3, 4, or 5, that kind of charge. Yeah, so should I scroll down, guys?
Yes, sir.
Yeah, done, guys.
Yes,
Okay, so let's say that we have multiple charges. So this was potential energy due to 2-point charges. Okay, so for the case of multiple charges, let's say that I have 3 charges. Okay, so let's say I have 3 charges. Let's say this is Q1, Q2, Q3. Okay, so for the case of 3 charges, what would be the potential energy? Let's say that I want to calculate from here. Okay, so first, how many interaction would be possible? So first would be this, and first would be this, and the other would be this, right? So 2 interactions. And what is the remaining interaction? Yes. So this is the remaining interaction. So this is how we calculate. So we count how many interactions do we have. Okay. So the potential energy of this system would be how much? This would be first due to this one and this one. So K Q1 Q2 by R1 plus due to this one. So K Q1 Q3 by R2, and then this one and this one. So K Q2 Q3 by R. So yeah, if we know that, then let us do one question. Okay. Yeah. So please note it down, guys, and then there is a general formula. So let's say that we have n number of charges, right? So Q1, Q2, Q3, Q4, and Q5, and so on. So the potential energy is written like this: 1 over 2 summation I and j, right? Where I not equals to j, and this goes from let's say n, right? So this would be qi qj divided by rij. Okay, and let me write it here. So I not equal to j. So this is the general formula. Why this half comes? Because you can have R12 and R21. So Q2, Q1, Q2, and Q2, Q1 both are same. So that is why this half portion take care of that. Yeah, this you don't need to understand. Just remember this one. So noted, everybody.
Yes, sir.
Okay, so now let us do one question, and I wanted to do the potential energy of dipole also, but I guess we have to do it in the next class. I wanted to start capacitor in the next class. And equipotential surface is a theoretical concept. Equipotential surface and conductors. So I will provide you the video lecture of that. So I will make a video and then I will provide you that, because that will take time and it will yeah, jeopardize our syllabus. So what I will do is that I will make a video on that and I will send it to you guys. Okay, guys.
Yes, sir.
Okay, so now let us do this question. We have four charges. This is q, this is q minus q minus q. Okay, so what would be the potential energy of this system? So first question is that what is the energy or what is the work done to make the system? Or first we should calculate what is the potential energy. Right. Second is that what is the work done to make the system? Right. We have brought these four charges in here at the corner of let's say square. So this is A. What would be the work done to bring them in this place? So, and the third is that what is the work done to break the system? Okay. So these are the three questions. I have 4 minutes. So let us solve this quickly. So how many interactions can we have? So let us start from one point. So at this point, let us start from here. So one would be this, right? Then one would be this, and then one would be this, right? Now let us take the other point. So at this point, right? This is done. So one would be this, and one would be this, right? So
Yes.
this is now let us move on to the next point. So let us move at this point. So at this point, how many interactions can we have more? Yeah, six. You said six. So yeah, 1, 2, 3, 4, 5, 6. Yes, total six. Absolutely right, Mariam. So we would have 1, 2, 3, 4, 5, 6 interactions. Right, Aisha? Yeah. So let us calculate all those energy. So potential energy, potential energy would be simply, first is this. So kq square by A, right? And then we have this minus kq square by, this is what? Root 2A, right? This distance is how much? So this is A, this is A, so this would be root 2A. Right, guys? So this is root 2A, so minus kq square by root 2A. And what else? Minus kq square by A. So this one cancels. And what do we have more? This one. So minus kq square by A, right? And then this one, minus kq square by root 2A. Okay. And then this one, plus kq square by A. So again, this one cancels and only two terms left. So this is minus 2kq square by root 2A. So this cancel and we have root 2. So minus of root 2 kq square by A. This is the potential energy of the system. Right, guys?
Yes.
So please quickly note it down. And work done to make the system. So potential energy is defined like that. Potential energy is work done to make the system. So W would be U, and this is again minus root 2 kq square by A. Right. And then the third one, to break the system. So this is negative of this work done. So minus of W, which is plus of root kq square by. So you guys quickly note it down, and in the next class we will start. Yes. Okay. Okay, Mariam. So Aisha, what about you? Done?
Yes, ma'am.
Okay. So yeah, tomorrow is a test, right? So you guys please take that test, that fortnightly test. Yeah, and the syllabus is on these topics. So potential energy will not be there, only the rest of the topics that I have taught you guys. And yeah, next class would be on potential energy due to dipole, and then we'll start capacitor and quickly finish that and start the third chapter. So what they are doing in your school, Asha and Maria? What are they doing?
Yeah, after the vacations, we're going to start the next chapter.
What they start?
We'll start the fifth chapter.
Fifth.
Yes, sir.